What is the total current in figure CC-T36-01? Of course, current is rated in amps, so our answers are indicated as either 10 amps, 3 amps, 6 amps, or 4 amps. Let's take a closer look at this circuit and try to identify what kind of mathematical rules we need to apply to answer this very simple Ohm's law question. Stay with me. All right, so I'm going to just focus in a little bit more on the circuit by expanding it. And we're going to identify the parts of the circuit together. So we have a voltage source of 120. You see E equals 120 volts. E, of course, means electromotive force, or V for volts. E and V are pretty much the same thing in an Ohm's law equation. So we have E or V at 120 volts. That's our total voltage of the source. Let's write that down. E total equals 120 volts. And of course, this particular circuit is clearly a series circuit. How do I know that? Well, because as long as there's circuit continuity and a couple of resistors here arranged and wired this way, what's really happening is current is going to be pushed from the source, and I'll use pink highlighter here to indicate current flow. This is the flow of electrons, of course, through the wires, and it's going to push through right up to the first resistor, which is R1, rated at 10 ohms. And all that current must pass through the first resistor before getting to the second resistor of 20 ohms. So when all the current has to pass through each consecutive resistor the way it's wired, we know that it's a series circuit. There are no parallel branches for current to split up and go in different directions. All the current has literally one pathway to flow. So we have a series circuit, and that's important to understand. Because once you know it's a series circuit, we can clearly use the right mathematical rules that apply to solving Ohm's law questions for series circuits. So let's start that. And remember, what do we have? We have a total voltage of 120. We've got two resistances, one at 10 ohms and one at 20 ohms. And we're trying to find the total current which is flowing. I paused because I don't know why Siri... because the word series is close to Siri.
Okay, disable Siri for now.
Yes, I will. She's off. I'm going to continue now with my video. I'm not going to end this video. I paused. Okay? So give me a second to recollect myself.
Your seconds are all yours.
Okay, as I was saying, we're going to find the total current here given two resistances wired in series. Let's move to another page, which is a little easier to perform the mathematics. So we'll take a look at it like this. And we have to remember that in any circuit, whether it's series or parallel, the total voltage of the source, represented as E total, will always equal the total current flowing through the circuit times the total resistance of the combined resistors in the circuit or the loads themselves. So we're really trying to find I total. We're going to rearrange this very quickly to say that I total is going to be equal to E total divided by R total. Just a quick algebraic manipulation of that equation. So what this really means is if I know E total and R total, I can calculate I total and answer our question. Well, it just so happens that we already know E total because it was provided in the original question, but we don't know R total. Now, in a series circuit, it's very easy to calculate total resistance. R total is equal to the sum of the individual resistors in the circuit. So R1 plus R2 plus R3, we can go on and on and on. For as many resistances are wired together in series. In our case, we only have two. And if we go back to the original question, just to be sure, we know we got one which is 10 ohms and one which is 20 ohms. So we're just going to plug those in. And we're going to say that our total resistance is equal to 10 ohms plus 20 ohms, which of course is simply 30 ohms. So now we know our total resistance is 30 ohms. Scroll up the page and let's do our final calculation. Total current is going to be equal to 120 volts divided by 30 ohms, which of course is going to be 4 amps. So we go back to our original question and let's just minimize this to look at our answers. And our answer must be D, 4 amps.